One of the problems that we've run into in the past was the calculation of one trigonometric function based on values about another trigonometric function. This is the same thing except using the double angle formulas. If sine of theta is equal to 3/5 and theta is in the second quadrant, determine the value of sine of 2 theta and cosine of 2 theta. Now it turns out for the cosine of 2 theta, we can calculate this right away. And the reason why is because there's a representation of this that only refers to sine of theta. And so this is 1 minus 2 sine squared theta. And so in this case, we're going to have 1 minus 2 times 3/5 quantity squared. And we just have to do the fraction arithmetic correctly. 3/5 squared is 9/25. 2 times 9/25, you might remember that if you have an integer, you could always put it over 1. So 18/25, 1 minus 18/25, which is equal to 7/25. And that's one of our two values. Now to get the value of sine of 2 theta, we actually need to know what the value of cosine theta is, because the formula of sine of 2 theta is 2 sine theta cosine theta. And that cosine theta value is one that we currently don't have. So let's take a look. Sine of theta is 3/5 and theta is in the second quadrant. So our theta looks like that. And we know that sine of theta is equal to 3/5. Now, just as before, we can use either an algebraic technique or a geometric technique here. So for the geometric technique, we want to think of this as y over r. For the algebraic technique, we use cosine squared theta plus sine squared theta equals 1, the Pythagorean identity, make a substitution, and go from there. In this case, I'm going to go ahead and use the geometric approach. So we have a right triangle, and here's our reference angle, which refers to, this triangle here. So we have y is equal to 3 and r is equal to 5. So y, the height is 3, and the hypotenuse is 5. You can see that this is going to be a 3, 4, 5 right triangle, but because we're going to the left side in the second quadrant, that 4 is negative. So we have cosine of theta is equal to negative 4/5. Now that we have this value, it's just a matter of plugging things in. This is equal to 2 times 3/5 times negative 4/5. I'll go ahead and put it over 1. 2 over 1 times 3 over 5 times negative 4 over 5. So it's going to be positive, positive, negative. So it's going to be a negative. The numerator, 2 times 3 is 6. 6 times 4 is 24. Denominator is 5 times 5, which is 25. So sine of 2 theta is negative 24/25. And then cosine of 2 theta is 7/25. Now, just like before, you will notice that we did not calculate what the angle theta really is. We only know these two values about it. We don't actually know the angle. And so that's one of the tricky parts about this, is that your job is not actually to find theta, but to use the formulas to calculate these particular values. And now we'll do an example of proving an identity using the double angle formulas. Prove that secant of 2 alpha is equal to secant squared alpha over 2 minus secant squared alpha. Now if you notice, this is actually a double angle formula for the secant function. All the functions have double angle formulas, and they're just going to be applications of these down here. So let's see how this one works. We are proving an identity, so we need to start from one side and work our way to the other. And typically we start from the more complicated side and work our way towards the simpler. In this case, the right-hand side is the complicated side. It's a fraction with secants in the numerator and the denominator. So let's start there. Secant squared alpha over 2 minus secant squared alpha. Now the first thing to observe is that all these functions down here involve sines and cosines. And so writing this as secant is not going to help us move forward. So we need to rewrite all of this as cosines. So 1 over cosine squared alpha, 2 minus 1 over cosine squared alpha. Okay, well now we've got the problem of fractions inside of fractions. Now we could try to multiply by the reciprocal of the denominator. That would require us to find like terms down here first, which we could do. But if we notice these fractions, the denominators of each of those fractions is exactly the same. And so in this case it makes more sense to clear those fractions by multiplying the top and the bottom by cosine squared alpha. And this will eliminate the fraction inside a fraction problem as well. So let's see what we have. If we multiply by cosine squared alpha, that cancels out that. So we have just a 1 in the numerator. Over, well, we distribute 2 cosine squared alpha minus 1. And the cancellation happens just like it did in the numerator. And now things are starting to look familiar. 2 cosine squared alpha minus 1. 2 cosine squared theta minus 1. So this is 1 over cosine of 2 alpha. And once we recognize this as a secant function, we are done. We've made it to the other side of the equation. So once again, it's a matter of just plugging stuff in, making substitutions, and following your nose on the algebra. There's no rule that tells you exactly what the next step is going to be. You just kind of have to look and see what you have and use that knowledge and your experience to go from there.